everyone, I'm going to show you how to fit your data and graph it. So the first thing we have to do is we need to make a new sheet. So go to where this plus sign says add sheet, click on it. Rename your sheet to effect of enzyme concentration scatter plot. So I'm going to demo this with enzyme concentration, but you guys, it's the same process for temperature and pH. So go back to your data. You got to copy this data over to your new sheet. So here's trial 1, here's trial 2, and here's trial 3. So now we transferred our data into a new blank sheet. Now we need to graph it. So select all of your data, go to Insert, Chart. So Excel automatically graphs your data, but we need to customize it a little bit. So under Setup, click on Line Chart, change it to Scatter Plot. That'll allow us to see the data a little bit better. Go to Customize, click on Chart Axis and Title. We're going to give the chart a title. So under where it says Chart Title, where it says this blank box right here, you're going to write the effect of enzyme concentration on catalase activity. So when we're naming charts, we always include the independent variable and the dependent variable in our title. So the independent variable was enzyme concentration, that's the thing we were changing, and the dependent variable is the catalase activity, or the activity of the enzyme. Now we have to label our X and Y axis. So click on chart title, change it to horizontal axis title, that's our X axis. Our X axis was time, so it's already labeled, so we don't need to change it. Click on vertical axis title. Under vertical axis title, the vertical axis is our dependent variable. That's the thing we were measuring. We were measuring the percentage of O2 production. So we'll say percent O2, that's what our sensor was picking up, and we're good to go. Scroll down to where it says series. We need to make the data points a little bit more fine so we can see them better. So under circle, click X instead. That helps us see the data a little bit better. Okay, so just from looking at this data, we can kind of qualitatively look at it and see that the yellow data looks like it's higher up, and it looks like the yellow data is not only larger in magnitude, but it also has a steeper slope, just from eyeballing it. But we can't just eyeball our data, we need to fit it. So double click the chart, go to Customize, click on Legend, no, not Legend, click on Series. Under Series, you want to click Trend Line. So what Excel just did was it drew a line of best fit through each of our data sets. So it kind of guesstimated which is the best line that will fit through each data set. We're assuming that our data is linear, so we'll keep it as linear. And under Label, we're going to change it to Use Equation, and then we're going to close out and see what we got. So what Excel just did was it took our data and drew a line of best fit through each of the data sets. And then it gave us an equation that describes each linear line of best fit. So for example, for the blue data, the equation that describes the line of best fit is 0.162x plus 16.6. This equation is in the format of y equals mx plus b, which is the linear equation formula. In this case, m stands for slope. The m is the number in front of the x. So the slope of the blue data is 0.162. That's the slope. Because slope is rise over run, slope is essentially percent O2 per second. So the greater the slope, the faster the reaction, according to our line of best fit. The slope for the red data is 0.133. So that's saying that the red data is increasing at a rate of 0.133% O2 per second. The yellow data has a slope of 0.146. So that's saying that the rate of this reaction is 0.146% O2 per second. So even though it looks like our yellow data, meaning 40 drops of enzyme, is the fastest reaction just from eyeballing it, if you look at the numbers, actually the fastest rate of reaction belongs to the 20 drops of enzyme suspension because that has the greatest slope. So you can eyeball the data and think to yourself, oh, probably the yellow data is the fastest reaction. But if you look at the line of best fit, actually it's this 0.162. That's the fastest rate of reaction. That belongs to 20 drops of enzyme suspension. So our line of best fit data would tell us that the 20 drops of enzyme suspension reaction went faster than the other ones.